Let me wait for few other participants. Then I'll start this. Yeah, fine, students. So let me start the session. Yeah, that's what I said, right? So for a try block, so let us assume I have a try block here. This is a try. Okay, this is a try block. So I open this try block. I close. Students, please mute your mic. Yeah. So for a try block, we can have at least one cache block, or we can have more than one cache. This is syntax. This is syntax or general form of exceptional handling. Okay, it begins with try block followed by one or more cache block. Okay, exception type. It can be any exception type, or I can pick it as arithmetic exception, followed by exob means nothing but exception object. So we are taking the variable e as exception object. And again, we can have one more cache block. So let us assume this, the second exception type is array index out of bound exception. And this exception object, again, let me pick the variable as e. It can be any variable name of your choice. So like that, what we can have, we can see dot indicates we can write n number of cache blocks. We can write n number of cache blocks. There's no constraint. So finally, what we should write? So finally, you should write yours finally block. Finally, you should write this finally block. Okay. So this is the general form or syntax of your exception handling. This is very, very important. This is very, very important. Okay. It's the general form of this exception handling. Okay. It's quite simple. It's nothing tough. Okay. The most important thing is this is optional. It is not mandatory. This is optional. Okay. Final block is optional. It is not mandatory. But for every try block, at least we should have one cache block. For a try block, at least we should have one cache block, or we should have this finally block. That's very, very important observation which you need to make it up. Yeah, fine. One more thing I would like to discuss. Yes, listen, students. This is very good code. Okay. The heading is what is the heading? Custom exceptions. That's it. Yeah. The heading is creating your own exceptions. Creating your own exception. That's what creating your own exception. What is own exception? See, students, up to now we have seen few arithmetic exceptions. Up to now we have seen few exceptions. What is few exceptions? And let me pull this slide. See. Slide. Yeah. You can see the students here. We have some exceptions out there, right? So all this arithmetic exception, array index out of bound class, all these exceptions are inbuilt exception. All these exceptions are inbuilt. All these are inbuilt exceptions. All these are inbuilt exceptions. What mean inbuilt? All these exceptions are present in a package called java.lang. All these exceptions are present in a package called java.lang. So that's why whenever an exception is printed on your screen, you'll be seeing an output something like this. That is java.lang.arithmetic exception. So why you're seeing like this? Because this arithmetic exception belongs to a package called java.lang. So here in the screen, as you see that there are several exceptions out there. All these exceptions are present in a package called java.lang, right? Now what we are seeing, here custom exceptions, or we call this creating our own exceptions. You see that here. Here it says that creating your own exceptions means I want to create my own exception. For example, I want to create an exception with the name called Sham. That's for fun. Okay, I want to create an exception with the name called Sham, or I want to create an exception with the name called my exception. I want to create an exception with a name called my exception. You see that, students, these two exceptions are not present in a package called java.lang. These two exceptions are not present in a package called java.lang. Why? Because I'm trying to create my own exception. That's what it is, own, and we call this as custom exception. Sometimes we call this as custom also. Custom means it's our own exception, right? So how to create your own exception inside your Java program, or we call it as how to create custom exceptions. So in order to do that, what we should do it? That's very, very important. That's what we're going to see. Okay. So whenever you want to create your own exception, how to do it? Second, let me put everything in a single frame. Yeah, fine. So how to create your own exception? In order to create your own exception, you need to write a class. Okay. The name of the class is nothing but it is a name of your own exception. It's a name of your custom exception. It is a name. It is a name. It's the name of your. It is a name of your own exception. It's a name of your own exception. Name of your own exception. Okay. Now here I'm trying to create my own exception called my exception. So whenever you want to create your own exception, okay, you need to write a class with respect to that name, followed by this class should extend a class called exception. Okay, it's mandatory. Okay, when you're trying to create your own exception, we need to write a class that extends another class called exception. This exception is an inbuilt class which is present in a package called java.lang. Okay. This exception class is an inbuilt class which is present in a package called java.lang. So whenever you want to write your own exception, you need to write a class which extends another class called exception. And this exception class is present in a package called java.lang. Okay, that's first thing. Okay, next instead is what I've written. I've written a constructor. Okay, you see that what is the name of my class? It is my exception. The name of my constructor also it is my exception. And inside I pass an argument, that is integer argument. And next inside this I've taken a variable called detail. It is not mandatory that you should take a variable name as detail. It can be any variable name of your choice. Okay, and then this instance variable detail I was assigned to this local variable called a. Okay. And next, inside this my exception, I've written a method called toString method. I've written a method called toString method, and this toString method is going to return string. It's going to return a string, and this method is of public. This method is of public. And inside this, what I'm trying to do, I'm trying to return a string. And what's a string I'm trying to return? I'm returning a string called my exception, and detail is nothing but the corresponding value. So what value I'm trying to set? That value I'm trying to append it, this value I'm trying to append to this my exception. Anyhow, once I run this program, it will be very clear for you. Okay. Now you see that's what I've written my own exception, right? I've written my own exception. Now see that. Now control execution begins from main method. Control execution begins from main method. Inside this main method, I'm trying to call a method called compute. I'm trying to pass a value called 1. So whenever you try to call a method called compute, so where the control goes, and there's a compute method. Yes, you can find here a compute method is there, right? I'm trying to call this compute. So control jumps to this compute method. Control jumps to this compute method. And what I'm trying to do, I'm trying to pass a value called 1. And what's the value of a? The value of a is 1. I'm trying to print system.out.println called compute. So it will print. So what it will print? It will print called compute. It will print a value called 1. Okay, value called 1. It will print it. Next, I'm checking if a is greater than 10. Is 1 is greater than 10? 1 is greater than 10 students? No, 1 is not greater than 10. If 1 is not greater than 10, I'll get an output called normal exit. I'll get an output called normal exit, right? That's first case. And second case, so again, I'm trying to call the compute method. I'm trying to pass a value called 20, and this 20 will go to here, right? Again, I'm trying to call this compute method. Okay, now I'm trying to pass a value called 20. What's the value of A? The value of A is 20. Okay, again, I'm trying to print called compute of 20. I'm trying to print called compute of 20. I'm checking if the 20 is greater than 10. 20 is greater than 10. Yes, 20 is greater than 10. If 20 is greater than 10, you see that I'm trying to throw my own exception. You see that? You see that previously we used to throw new arithmetic exception. Now you see that I'm trying to throw my own exception. That is my exception. Here you see that I'm trying to pass the value called A. And what is the value called A? The value called A is nothing but it is 20, right? Now, one important thing you should observe here is, see, you see that what is this new? It's nothing but I'm trying to create an object. I'm trying to create an object of a class called my exception. Okay. So whenever we create an object of a class, where the control goes to the constructor. Control goes to the constructor, right? Means inside the class called my exception, I need to find a constructor which is taking one argument, and this argument must be of type int, right? It must be of type int. So that's why you see that. So that's why you can see that here I've done this corresponding constructor. I've done this corresponding constructor. Okay. So this constructor is taking one argument which is of type int. So when I write like this, throw new my exception of passing 20, right? So when I do like this, what's going to happen? It's nothing but I'm trying to create an object of this class, right? When I try to create an object of this class, I need to find a constructor which is taking one argument of type integer. So therefore, I have done this constructor inside the class called my exception, and this 20 will go to A. And what's the value of detail? The value of detail is nothing but it is 20. The value of detail is nothing but is 20, right? Now, in cache block, if I write system dot out dot print E. If I write E, I'm trying to print exception object. When I try to print an exception object, it's going to invoke the corresponding toString method. When it's going to invoke the corresponding toString method, what's going to happen? It prints my exception. Plus detail. And what's the value of detail? The value of detail is something that is 20. So it prints 20. So in the output, I'll get my exception in square bracket. I'll get the value called 20. Print like that, right? Anyhow, you can see that. That's what he's trying to do it. Okay, so what I'm trying to students here, if 20 is greater than 10, since 20 is greater than, I'm trying to throw an exception. Where I'm trying to throw exception? Inside this compute method, I'm trying to throw an exception. You see that compute is not handling this exception. That is, I have not placed inside this try and catch block. This throw statement, I have not placed inside the try and catch block. Since I have not placed inside the try and catch block, this exception is thrown back to the main method. Why it is thrown back to the main method? Because it is a main method which is called this compute. So the main method has to handle this exception, that is my exception. How it is trying to handle? By placing the code inside this try and catch block. So since I written try and catch block, the control will jump to this catch block. And inside this catch block, I'll be printing caught plus E. So when I try to print the description of the exception, that is E, what's going to happen? This E, when I'm trying to print E, is going to invoke this corresponding toString method. And what this is trying to do is trying to return this value, that is exception square bracket 20, right? And that's what I'll be getting the output. You see that is the output we'll be getting. One second, students. Let me put correspondingly so that they can understand. Let me share my complete screen. Yeah, you can see that output. We got the same expected output, right? So initially I'm trying to call compute of 1. Okay. Control execution begins from main method. Compute of 1. The code jumps inside this compute. Okay. Into this compute. What I'm trying to do. 1 second. Yeah. Yeah. So what I'm trying to do, code jumps inside this compute, and inside this compute, what I'm trying to called compute of A. And what's the value of A? That is 1. So it is printing call compute 1. That's what it's printing. Next, I'm checking whether 1 is greater than 10. 1 is greater than 10. No, 1 is not greater than 10. So therefore, the statement will not be executed. It comes to this statement. I'll get normal exit. So therefore, I got normal exit, right? So that's all. That is the first case. First case. And the second case, in the second case, again, this I finished. So again, I'm trying to call compute. This time I'm trying to pass the value called 20. Now, what's the value of A? The value of A is nothing but is 20. So I'm trying to print system.out.println call compute. And what's the value? It is 20. So therefore, I'm getting call compute of 20, right? Next, I'm checking whether 20 is greater than 10. 20 is greater than 10. Yes, it is greater than 10. So this statement is trying to throw an exception. What exception is trying to throw? Is trying to throw my own exception, that is new my exception, right? So when an exception is thrown, so you see that this method called compute is not handling this exception. See, one important thing, since this method is not handling this exception, you see that this behavior has been mentioned using this throws keyword. That's very, very important. That's very, very important. You see that after defining the method, you see that they use throws my exception. Why? They return throws my exception because this method called compute, is trying to throw an exception called my exception, but this compute is not handling. Since the compute is not handling this my exception, this behavior we needs to mention using this throws class, right? So when exception is thrown, the exception is thrown back to the main method. It is thrown back to the main method, and the main method is trying to catch this my exception. So therefore, the control goes to this catch block. In the catch block, I'll write caught. Writing caught. E is nothing but I'm going to print the description of the exception. And what's the description? That is my exception of 20. Okay. So in order to print the description, what we should do it? In order to print the description, that's very, very important. In order to print the description, it is mandated that you need to override this toString method. It is mandatory. In order to print the description of the exception, it is mandated that you need to override this toString method. Okay. We need to override a method called toString method. And return type of this toString is nothing but is string. Yeah. Finished my discussion. Any questions you can ask. The most important thing is, okay, compute method is trying to, you see that here I've used a throws class. Why? Because the compute method is trying to throw an exception called my exception, which the compute method is not handling. So this behavior we need to mention using this throws keyword. Is it right, students? That's one thing. And the next important thing is, so whenever you want to create your own exception, custom exception, we need to write a class which extends exception. We need to write a class which extends exception. And then we need to write this corresponding toString method. Why this corresponding toString method? In order to print the description of the exception, it is mandated that you need to override this toString. So what do you write here? The same thing will be printed. So exception of 20. I have finished, students. You have any questions, you can ask. Otherwise, you can leave the session. And that's all for today's class. Have a nice day. Have any questions, you can ask. Otherwise, you can leave the session. Yes. Any questions, students, you can ask. No questions, you can leave the session. Okay, students, have a nice day.